Okay, so for question number 34, we have to find the vector and Cartesian equations of the line passing through the point 1 to minus 4 and parallel to the line joining the points. So let's first of all find out the Cartesian and vector equations of the line passing through the points. So I'm going to keep this question here. Okay, so now we have to find the vector and Cartesian equations of the line passing through the point. So we know that vector equation and the Cartesian equation. So vector equation of a line passing through a point and parallel to a given vector. So passing through a given point and parallel to a given vector is given by, let's write down the formula. So this is given. So it's passing through a point. Let's say the point is x1, y1, z1, and is parallel to the vector b. So the vector equation of the line is given by r vector is equal to a vector plus lambda into b vector, where a is the position vector of the point and b is the parallel vector. So the for the first one, r position vector. So the r Cartesian equation is now the position vector of 1 to minus 4 is I cap plus 2j cap minus 4k cap. This is the position vector. So we are going to put the value here I cap plus 2j cap and a negative 4k cap plus lambda into b vector. Now b vector is the parallel vector and this line is parallel to the line joining the points. So let's keep this as equation 1. And the b vector is the parallel vector which is passing through A and B. So our B vector would be position vector of B vector minus A vector. So this would be the B vector. So this would be B is its I cap and minus 11j cap minus position vector of A. This is the position vector of A, which is 3I cap plus 3j cap minus 5k cap, which gives me I cap minus 11j cap minus 3I cap minus 3j cap plus 5k cap. So this is now minus 2I cap minus 3j cap and minus 6k cap. Okay, so let's put the value here. And so this r vector, so this r vector becomes its I cap plus 2 cap 2j cap minus 4k cap plus lambda into minus 2I cap minus 3j cap minus 6k cap. Okay, now I can write it as it's I cap plus 2j cap minus 4k cap plus lambda. If I take out negative common, so that would be plus negative lambda into 2I cap plus 3j cap plus 6k cap. Okay, now negative lambda is also constant, so I'm going to write it as lambda. So this is minus 4k cap plus lambda into 2I cap plus 3j cap plus 6k cap. And let's say this is our equation 1. So this is the equation of the line that is passing through this point and parallel to the line joining these points. Now the Cartesian equation, let's also write down the Cartesian equation of this line. So Cartesian equation of the line is given by of a line passing through a point x1, y1, z1 is given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c, where x, y1, and z1 are the coordinates of the points. So coordinates of the points are 1 to minus 4. So this is 1, 2, and minus 4, which will be 4. Okay, now A, B, and C are the direction ratios of the B vector. So this is our B vector and its direction ratios are 2, 3, and 6. So this is 2, 3, and 6. So this is the Cartesian equation, and this is the vector equation of the line passing through the point and parallel to the line passing through the given points. Okay, now let's also write down the equation of the line that is passing through these 2 points. So our points are A is 3, 3 minus 5. So this is 3, 3 minus 5. And B is 1, 0 minus 11. Now, equation of a line passing through 2 points, its vector equation is given by its x. So vector equation of a line passing through 2 points is given by r vector is equal to a vector plus lambda into b vector minus a vector. Okay, so a vector is the position vector of the point A. So this is 3i cap plus 3j cap minus 5k cap plus, let's say this is not a lambda this time, let's say it's new. So this is new and a new. So B minus A vector. B minus A vector. B is the position vector of point B. So this is I cap minus 11j cap minus A is the position vector of the first point 3i cap minus 3j cap plus 5k cap. And if I simplify this, this would be 3i cap plus 3j cap minus 5k cap plus nu into I minus 3i is minus 2i cap minus 11. This is actually k cap minus 11k cap. So first of all, let me write down the j caps minus 3j cap and minus 11 plus 5 is minus 6k cap. And if I take negative common here, so this is 3i cap plus 3j cap minus 5k cap and negative nu. So this is plus into negative nu, and negative nu is still a constant, so I will write it as nu. So plus this is 6k cap. So this is r vector is equal to 3i cap. So this is 3i cap plus 3j cap minus 5k cap, and this is negative nu, still a constant, so I will keep it as nu. It's 2i cap plus 3j cap plus 6k cap. This is our vector equation, and the Cartesian equation of a line passing through 2 points. Let's write down the formula first. So this is x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1 is equal to z minus z1 upon z2 minus z1. Okay, let's put in the values for x minus x1. So x1 is 3, so this is 3, and x2 minus x1. So 1 minus 3 is negative 2, y minus y1 is 3, and y2 minus y1 is 0 minus 3, z minus z1 is plus 5, and z2 minus z1 is 11 minus 11 plus 5, which is negative 6. So this is the Cartesian equation, and this is the vector equation. Okay, now let's see what is asked next in the question. So this is, we have to find the distance between two lines. So the distance between, so these two lines are parallel. So this is one line which is passing through a point, and this is the line which is passing through 2 points, and these 2 points are A and B. And the first point was 1, 2, minus 4. So we have got the equation. So 1, 2, minus 4 was the first point. So this is 1, 2, minus 4. and the others were 3, 3, negative 5. So 3, 3, negative 5, and B was 1, 0, and negative 11. Okay, now we have to find the distance. That is a perpendicular distance. These are the parallel lines, and distance between parallel lines is given by A2 minus A1 vectors cross with B vectors magnitude divided by magnitude of B vector. So this is the distance between the parallel lines. So first of all, let's find out the distance difference between A2 and A1. So A1 is, so this is our second equation. So this was the second equation, and this is our A2. So this is our A2. So this is 3i cap plus 3j cap minus 5k cap. So this is from this line we got A2. So this is A2, and now I'm going to get this is A1. So A1, we will get it from the first equation. So A1 is from first equation. This is also our first equation. And A1 is I cap plus 2j minus 4k. I plus 2j minus 4k. So this is I cap plus 2j minus 4k cap. And now let's find out the difference. So the difference and then the cross product with B. So our difference here is, okay, we also write down B vector. So B vector is the parallel. This is, and because these two lines are parallel, so both of them have the same B vector, 2i plus 3j plus 6k. It's 2i plus 3j plus 6k. So this is 2i plus 3j plus 6k. So we have the required information to find the distance, and now let's find out A2 minus A1. So A2 minus A1 vector is 3 minus 1 is 2, 3 minus 2 is 1 j cap, minus 5 plus 4 is negative k cap. So 2i plus j minus k, and b vector is, so this is A2 minus A1, b vector is 2i cap plus 3j cap plus 6k cap, and now we have to find their cross product. So cross product of A2 minus A1 with B is that of IJK. So this is IJ cap, K cap, and A2 minus A1, it's 2, 1, minus 1. This is 2, 3, 6. We have to find the determinants. So this gives us I cap into, it's 6 plus 3 minus j cap into 12 plus 2 and plus k cap. K cap is 6 minus 2. So which gives us 9i cap minus 14 j cap plus 4 k cap. So this is 9i cap minus 14 plus 4 j cap, and now we have to find the magnitude of this, which would be under root 9 square minus 14 square plus 4 square. So 9 square is 81, 14 square is 196, 4 square is 16, which gives us 6 plus 6, 12, and 13, 9, 10, and 8 is 18, and 19, and 19, this is, so 293. This is under root 293. And now magnitude of B. So B vectors, magnitude B vector is 2, 3, 6. So it's square of 2, 3 square plus 6 square under root, which gives us under root 4 plus 9 plus 36, which is under root 49, and this is 7. So D is equal to under root 293 by 7, units. Okay, so this is the perpendicular distance, and we have got the equations as well, the vector equations and the Cartesian equations. Vector and the Cartesian equation. So this is the Cartesian equation, this is the vector equation. Okay, moving on to the second part of this question. Okay, we have to find the equations of the line passing through A and B and hence find the coordinates of the points on this line which are at distance of 14 units from point Q. So let me just erase this. So, all right, so we are on to the second part of the question. And the second part of the question is we have to find the equations of the line passing through 2 points. So it's written equations. So we will find both. Let's try to get we can get both the Cartesian and the vector equations. So Cartesian vector equation of a line passing through 2 points is given by its r vector is equal to a vector plus lambda into b vector minus a vector, where b and a and b are the position vectors of the point. So a vector is, this is I cap plus 2j cap plus 3k cap plus lambda into b. B vector is 3i cap plus 5j cap plus 9k cap and minus position vector of a, which is I cap minus 2j cap minus 3k cap. Okay. Now this is I cap plus 2j cap plus 3k cap plus lambda into 3 minus I is 2i cap, 5 minus 2 is 3j cap, 9 minus 3 is 6k cap. So this is the vector equation, and we can also write down the Cartesian equation. So Cartesian equation of a line passing through 2 points. So this is x minus x1 upon x1 minus x2, or and this is y minus y1 upon y2 minus y1. Okay, this is x2 minus x1, and this is z minus z1 upon z2 minus z1. This is the Cartesian equation. Let's say this is equal to some constant, let's say lambda. Okay, now x minus x1, so this is the points are 1, 2, 3, and 3, 5, 9. So this is 3, 5, and 9. So this is x minus x1, which is 1, and 3 minus 1 is 2, y minus y1 is 2, 5 minus 2 is 3, z minus z1 is 3, and 9 minus 3 is 6. Let's say this is equal to lambda. Okay, let's equate it to lambda and get our coordinates in terms of lambda. This is z minus 3 by 6 is equal to lambda. Okay, this is x minus 1 is equal to 2 lambda. So x is equal to 2 lambda plus 1. Y is equal to 3 lambda plus 6. And z is equal to 6 lambda plus. Okay, so we have x, y, and z in terms of lambda. So moving on to the next part, we have to find the coordinates of the points on this line which are at a distance of 14 units from point B. So we have to find the coordinates of the points on this line. So this is point A and this is point B. And there is a point, let's say x, y, z with x, y, z coordinates. And this is at a distance of 14 units from B. So this is at a distance of 14 units from B. And the coordinates of B are 3, 5, and 9. So 3, 5, and 9. Okay, let's say for some value of lambda, this x is this coordinate and this y is this and z is this. So let's say this point is P. So it's given that PB is equal to 14 units. So how do we find PB using the distance formula? So PB using the distance formula, we know that it's x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. The whole thing is under root, which is equal to 40. Okay, now let's put in the values. This is x2, so 3 minus this is x the whole square plus, and y2 is 5 minus y1, which is y the whole square plus z2 is 9 minus z the whole square under root. And now let's say for some value of lambda, this x, y, and z are these. So let's put the value of x in terms of lambda. So this is 3 minus, this is 2 lambda plus 1, the whole square plus 5 minus y is 3 lambda plus 2, the whole square. 9 minus z. Z is 6 lambda plus 3 the whole square, where 6 lambda plus 3 the whole square is equal to 40. And this whole thing is under root. We can take that under root of by squaring on both sides. So let's square on both sides as well. So square on both sides will take off the under root sign. So this is a minus b the whole square, which is a plus 2 lambda plus 1 the whole square minus 2 into a into b. Okay, or let me just solve it inside the bracket. Okay, so this is 3 minus 2 lambda. I can write it as 3 minus 2 lambda minus 1 the whole square plus 5 minus 13 lambda minus 2 the whole square plus 9 minus 6 lambda minus 3 the whole square is equal to 196. So 3 minus 1 is 2. This is 2 minus 2 lambda the whole square plus 5 minus 2 is 3 minus 13 lambda the whole square. So it's y is equal to 3 lambda plus 2. So this is 3 lambda. So this is 3 lambda. And this is actually 3. This is 5 minus 3 lambda, 9 minus 6 lambda minus 3. Okay, so this is now 3 minus 3 lambda the whole square plus 9 minus 3 is 6 minus 6 lambda the whole square is equal to 196. Okay, so this is now a minus b the whole square, which is a square plus b square minus a2 into a into b, a square plus b square minus 2 3 6 these are 18 lambda plus a square plus b square 6 to the 12 12 6 are 72 lambda is equal to 196. Okay, now it's 2 lambda square plus 9 lambda square is 11 11 plus 36 11 plus 36 is 47 lambda square minus 8 lambda minus 18 lambda is 26 26 and 72 is minus 98 lambda. This is 2 lambda square. Okay, this is done. This is 4 plus 9 is 13 and 13 and 36 is 49 is equal to 196. So this is 47 lambda square minus 98 lambda. And this is now plus 49 minus 196 is equal to 0. Okay, so this finally is 47 lambda square minus 98 lambda, and this is minus 16 minus 9 is 7. 8 minus 4 is 4. 147 is equal to 0. And for this, let me take, okay, this is 196 and this is 49. So 196 minus 49, 16 minus 9 is 7. 4, 147. Okay, let me just check it once again. This was 3. X was equal to, this is 2 lambda, 2 lambda minus 2, 3 lambda minus 3, and 6 lambda minus 6. So this gives us 2 to the 4, 4 to the 8, 3 to the 3 to the 9, this 2 to the 6, 6 to the 18, 6 to the 12, and 12, 7 is 12, 6 to the 12, 6, 6 to 12, and it's 72. So this is 47, 98, and 4 and 9 is 13. 13 and 36 is 49. 14 square. So 14 square is 196. Okay, so this is, okay, so we have this quadratic equation which is 47 lambda square minus 2, 47 lambda square minus 98 lambda minus 147 is equal to 0. And if I take 47 common, so this is lambda square minus, it's 47 to 7 to the 14 to 4, that it should be 94 as well. Okay, so 3, 2 minus 2 lambda, and 3 minus 3 lambda, and 6 minus 6 lambda. 2 square is 4, 2 is, this should be 4, and 3 square and 9, 2 square, 4, 3 square, 3 square, 6 square is 36, 36. Okay, now this is 47. Now we have 4 lambda square plus 9 is 13, and 13 and 36 is 49 lambda square. So this is actually 49 lambda square. So this is 49, 49, 49. Okay, now if we take 49 common, this is lambda square, and 49 to the is 98, and 49 3 are is 147. So this is lambda square minus 2 lambda minus 3 is equal to 0, and this is a quadratic equation, so it's 3 lambda plus lambda minus 3 is equal to 0, which gives lambda into lambda minus 3 plus 1 into lambda minus 3 is equal to 0. So either lambda plus 1 is 0 or lambda minus 3 is 0. So either lambda is equal to -1 or lambda is equal to 3. And now our required points are, when, let's say, when lambda is equal to 1, when lambda is equal to -1, so our required points will be, required points are x is equal to 2 lambda plus 1. So x is equal to 2 lambda plus 1. Y was equal to 3 lambda plus 2. So this is 3 lambda plus 2. And z was equal to 6 lambda plus 3. So this is 6 lambda plus 3. Okay, now lambda is equal to -1. So x is equal to 2 into -1 is -2 plus 1. This is -3 plus 2, and z is equal to -6 plus 3. So x is equal to -1, y is equal to -1, and z is equal to -3. So the required point is -1, and 3 when lambda is equal to uh, -1. And let's find out when lambda is equal to 3, what would be our points. So when lambda is equal to 3, x. So when lambda is equal to 3, x would be 2 into 3, 6 plus 1, 7. Y is equal to 3, the 9 plus 2, 11. And z would be 6 here, 18, and 3, 21. So x, so this would be 7, 11, and 21 would be the required points. Okay, so it's either -1, and this is -3, or 7, 11, and 21, 7, 11, and 21. And this finishes our question number 34. Let's move on to question number 35.